Unit 11, Day 4. Inverse trig functions, not on the unit circle. So I don't know if that's good or bad, I guess. If you know the unit circle well, you might not like these because they're not on the unit circle. If you don't know the unit circle well, you'll prefer these because you don't have to know the unit circle to get these correct. Let's just quick review here. So, ka, toa, just reminding you of the things we need to know for this lesson. Opposite over hypotenuse is also y over r. Adjacent over hypotenuse is also x over r. And tangent we talked about earlier was opposite over adjacent, but you've switched to saying y over x or sine over cosine. And then I'm going to do that picture that I did yesterday, where 1 and 2 is inverse cosine and his friends. Inverse cosine, inverse secant, inverse cotangent come from 1 or 2. 1 and 4 is inverse sine and his friends. Inverse sine, inverse cosecant, and inverse tangent. That's all old news, or at least it should be old news. So this next set of problems, and we're just going to jump in and do some examples, are picture problems. So the sine of the inverse cosine of negative 4/5. The sine of the inverse cosine of negative 4/5. Well, as with all math stuff, you start on the inside and work your way out. So inverse cosine of negative 4/5. That means find an angle whose cosine is negative 4/5. Well, that's not a unit circle thing. Like 4/5 was not on the unit circle. But maybe I could draw this and at least draw the angle that represents or has a cosine of negative 4/5. Let's see. Cosine is adjacent over hypotenuse, or x over r. You can think of it either way. X over r might be better. Inverse cosine has to come from 1 or 2. It's negative, so it's got to come from 2. So I'm going to just draw a triangle in quadrant 2. The adjacent side, the x side, is 4. Negative because it's backwards, or negative because it's negative. It told me it's negative. The radius is 5, or the hypotenuse is 5, either way. So we use the inside stuff to draw the triangle. And then we use that outside one. We use the triangle that we drew to figure out whatever we need to find out. So sine is opposite over hypotenuse, or y over r. Except I don't have the y or the opposite over here. But that's an easy one. What's the missing side? A squared plus b squared equals c squared, or it's a special right triangle that we all know and love. Yeah, 3, 4, 5. So it's 3. You do have to be careful about positives and negatives, but since it's up, it's positive, so 3, positive 3. And then y over r, or opposite over hypotenuse, either way, is 3/5. So use the inside to draw the picture, And then you use the picture you drew to answer the outside question. And I guess it's a little bit weird because inverse cosine means find an angle, and we didn't ever find a value for that angle. Like, there's the angle. We never really found that angle. And we didn't find a value for that angle. I guess we could say we found the angle. It was right there, and we had enough information to give the sign of it. Tangent of the inverse sine of 8/17. What quadrant am I going to draw my picture in? Yeah. Quadrant 1, because it's positive. Sine is opposite over hypotenuse. So, yeah, I'm kind of switching. I'm not drawing my triangle to scale necessarily like it was imported to in the unit circle. I guess you could if you wanted to, but I'm not really worried about it. Hypotenuse is 17. Opposite, or y, if that helps, is 8. That's another Pythagorean triple. Maybe out to the side we should remind ourselves of what some of these are. 3, 4, 5. Remember what the next one is? No, we don't ever use those. 5, 12, 13. And 8, 15, 17. If you remember those, it makes life a lot easier because most of these questions work out to be nice triangles. Not all of them, but most of them do. So the missing side is 15. If you forget it, then you just have to do 8 squared plus b squared equals 17 squared. And a little bit later, you'll figure out that d is 15. 15. But if you know the Pythagorean triples, it makes life a lot easier. Those show up on SAT questions a lot as well, where if you know them, it just makes the problem a lot easier. And on a tightly timed test, it's sure a lot nicer to know those than to, a squared plus b squared equals c squared. And yes, you can get it, but this saves you, or can save you, a lot of time. All right, so inside stuff we use to draw the triangle. Tangent, we'll use the triangle. Opposite over adjacent, or y over x. So y is 8, x is 15, so 8/15. Inside stuff, draw the triangle. Outside stuff, use the triangle. Well, let's see if we can make it complicated here. Secant of inverse cotangent of negative 5/12. All right, same process, just a little harder because we're not as familiar with cotangent and secant probably. Cotangent has got to come from 1 or 2. This one's negative, so it's got to come, or it's got to be in quadrant 2. What's cotangent equal to in terms of opposite, adjacent, and hypotenuse? X over y. That's an even better way to say it. Because it's the flip of tangent. So instead of y over x, it's x over y. So x is 5. Y is 12. One of them is negative. The backward one is negative, so negative 5, 12. And what's the hypotenuse? 13. Good. Now we all know our units, our Pythagorean triples. We save ourselves a little bit of time. So 5, 12, 13. So got the triangle drawn. Secant is, well, the flip of cosine, so h over a or x over r. Nope. X over r would be cosine, so r over x. So 13 over negative 5. Use the inside information to draw a little picture, then use the picture to answer the outside question. Speaking of throwing you curveballs, tangent of the inverse sine of 4/3. Tangent of the inverse sine of 4/3. Why don't you see if you can do that one? So draw the picture and see if you can figure out the tangent. And caution, there's a bit of a trick on this one. So you can draw the picture and then something funny should be happening. Let's see. Inverse sine's got to come from 1 or 4. This one's positive, so it's got to be in 1. Let's see. Sine is opposite over hypotenuse, or y over r. So 4 over 3. Good. I see some people shaking their head like, wait a minute. Why are we shaking our heads on that? What's not right about that? Right, the hypotenuse is supposed to be the longest side, so I can't have a hypotenuse that's shorter than a side. Like this doesn't make sense. There's no way to draw a triangle where that's actually true. I suppose you could keep going and try to figure out what A is, although some people are going to say, oh, it's a 3, 4, 5 right triangle, which really wouldn't make sense to have hypotenuse the shortest of the sides. A squared plus 4 squared equals 3 squared. Again, hopefully you've bailed on this problem before now, because a squared is -7. That doesn't really make sense. So this doesn't work. No solution, or no triangle. You can't draw a triangle that fits that. So the assignment is, and we'll work one together, because there's one more kind of tricky thing. Assignment's worksheet 5, 25 through 45. And we're not going to do the calculator stuff at the end, the 46 through 63. So you can mark those out at the very last set. We're not ever going to do those, so you can just mark those out. They're super easy. All you do is type them in a calculator. All right, where's one that I want to look at? Let's look at number 30. Got one extra trick in it. Most of you, I think, figured it out right away. But just in case, let's look at number 30. Sine of the inverse cotangent of 4. All right, cotangent's got to come from 1 or 2. It's positive, so it's definitely going to be in quadrant 1. Cotangent is the opposite of I won't say the opposite, the reciprocal of tangent. So cotangent is x over y. So how am I supposed to do this if there's just a 4 there? It's not a fraction. Yeah, make it 4 over 1, and then you can line up things. So if you get one that's not a fraction, well, make it a fraction by putting it over 1. So x is 4, y is 1. And then a squared plus b squared equals c squared. So that's not a nice one. That one ends up being square root of 17. Sine is y over r. So 1 over square root of 17. And when we fix that, square root 17 over 17. So Definitely wanted to do 30 because it had you had to make it into a fraction so that it would work, and it was not a nice right triangle. You got a square root as part of your answer, but that's okay. So you can kind of tell right away if they're going to be nice or not, because you know the Pythagorean triples, 3, 4, 5, 5, 12, 13, 8, 15, 17. You see a whole lot of those numbers on here, so a whole lot of them are nice. 29 wouldn't be nice, though. 2/3, that's not a Pythagorean triple. And then you flip it over, and some of the same type stuff is going on. All right, so that's the end of the new stuff. You have this worksheet already. I'm going to go ahead and give you the review worksheet so that if you want to start it, you can. Officially, it'll be tomorrow's assignment. It'll also be posted for you guys watching. And answers to all of these will be posted if they're not already. I think worksheet 5 answers are posted, and I'll post review answers shortly.